Welcome back to the solutions manual. In this video, we will solve the problem 2-71 from RC Hibbeler Engineering Statics 12th edition. According to this problem, if alpha is 120 degrees and beta has to be less than 90 degrees, gamma is 60 degrees, and f is 400 lbs, we have to determine the magnitude and coordinate direction angles of the resultant force acting on the hook. Now to solve this problem, first of all, we have to express each of the forces into their Cartesian vector form. So for force F, we have to find its one of the coordinate direction angles, which is the angle beta. So if you recall, we have this identity of cos square alpha plus cos square beta plus cos square gamma equals to 1. And if I substitute the known values, I would have cos square of 120 degrees plus cos square beta plus cos square gamma, which is 60 degrees, equals to 1. And upon further simplification, cos square beta comes out to be 1 upon 2. So if I take the square root on both sides, I would have cos beta is equals to positive root 2 upon 2, or cos beta is equals to negative root 2 upon 2. So from positive cos value, if you take the cos inverse of this value, you would get beta as 45 degrees. And from the negative cos beta, if you take the cos inverse of this value, then you would get the beta as 135 degrees. Since beta has to be less than 90 degrees as given in the problem statement, so this is the correct value of beta. So force F in terms of Cartesian vector form can be written as F cos alpha I plus F cos beta j plus F cos gamma k. And if we substitute the known values, we would have F is 400 lbs. So 400 into cos alpha. Alpha is 120 degrees. I plus 400 into cos beta. And beta is 45 degrees. Less than 90 degrees. J plus 400 into cos gamma, and gamma is 60 degrees. So upon further simplifications, F becomes negative 200I plus 282.84J plus 200K. Now we have to resolve the F1 force into the Cartesian vector form. So for F1 force, let's call this angle as theta. First of all, we have to draw the projection of F1 force on the XY plane, and it would look something like this. Let's label it. So this is F1 cos theta. And now we have to resolve this projection of F1 force into the components along the x-axis and the y-axis. So this is the component along the y-axis, and this is the component along the x-axis. The component along the y-axis becomes F1 cos theta into cos 30, and the component along the x-axis becomes F1 cos theta into sin 30. We have one more component for the F1 force, which is a negative z component, which is acting in a downward direction. This is the z component of F1 force, and it can be written as F1 sine theta. So these are the components of F1 force. So now we have to calculate the value of this angle theta. So for theta, we can consider this 3, 4, 5 triangle. It may not look like a right angle triangle, but this is a right angle triangle. And this angle is theta that we have to calculate. So for theta, we can do opposite, which is 3, over the adjacent, which is 4. So from here, theta comes out to be 36.87 degrees. F1 force in terms of Cartesian vector form, we have F1 cos theta. Theta is 36.87 degrees into sine 30 I plus F1 cos theta, and theta is 36.87 into cos 30 J minus F1 sine theta. And why minus? Because it's a negative Z component. So negative F1 into sine theta. So sine 36.87 K. Since the magnitude of F1 force is 600 lbs, so if we substitute the values, we would have 600 into cos 36.87 into sine 30 I plus 600 into cos 36.87 into cos 30 J minus 600 into sine 36.87 K. So upon further simplification, we have F1 is equals to 240 I plus 415.7 J minus 360 K. So this is the force F1 in terms of Cartesian vector form. Now we know that the resultant force is the vector sum of the force F and the force F1. So if we add these two, we would have negative 200 I plus 282.84 J plus 200 K plus 240 I plus 415.7 J minus 360 K. So upon further simplification, adding the I components together, so it would be 40 I. Adding the J components together, so it would be 698.54 J. Adding the K components together, so it would be negative 160 K. So this is the resultant force in terms of Cartesian vector form. So for magnitude of the resultant force, we can use the Pythagoras theorem. So we have the square root of frx square plus fry square plus frz square. So this is frx, this is fry, and this is frz. Upon substituting the values, we would have 40 square plus 698.54 square plus negative 160 square. And upon simplification, the magnitude of the FR force comes out to be 717.75 lbs. So this is our first answer. Now for coordinate direction angles. Of resultant force, we have cos alpha for the resultant force is equals to FRX divided by FR, so equals to, so we have 40 over 717.75. So if you take the cos inverse of this value, then the alpha of the resultant force comes out to be 86.81 degrees. So now we have to do the same for the cos beta and cos gamma. So cos beta of the resultant force is equals to FRY over FR. So we have 698.54 divided by FR, which is 717.75. So if we take the cos inverse of this value, then angle beta of the resultant force comes out to be 13.29 degrees. And now for cos gamma, we have cos gamma of the resultant force is equals to FRZ over FR, and FRZ is negative 160. So negative 160 over 717.75. So if we take the cos inverse of this value, then gamma of the resultant force comes out to be 102.88 degrees. So to summarize, the magnitude of the resultant force is 717.75 lbs. Alpha is equals to 86.81 degrees. Beta of the resultant force is 13.29 degrees. And the gamma of the resultant force is 102.88 degrees. So these are our answers. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts about the resolution of forces or in the Cartesian vector form or even in the coordinate direction angles, then feel free to ask in the comment section and I will answer it as soon as possible. Thank you.